Hello and welcome. Here we'll solve one more example based on a Z transform. So Z transform, this is the definition of Z transform. We already studied it. X of Z is equal to n varies from minus infinity to infinity. X of n Z raised to minus n. Let's start the example. Here find Z transform and draw its ROC for the following sequence. And the sequence is x of n is equal to minus a raised to n u of minus n minus 1. Now we'll write the definition of Z transform. X of Z is equal to n varies from minus infinity to infinity. X of n Z raised to minus n. And our x of n is minus a raised to n u of minus n minus 1. Let's put this x of n here. Now the existence of this x of n. A raised to n exists from minus infinity to infinity, but u of minus n minus 1 exists only from minus infinity to minus 1, like this. U of minus n minus 1 exists from minus infinity to minus 1, where this a of n may or it exists from minus infinity to infinity, but this a raised to n get multiplied by 1 amplitude of u of minus n minus 1 from minus infinity to minus 1. For other values of n, this u of minus n minus 1 is 0. That's why this a raised to n also exists from minus infinity to minus 1. Otherwise, it will get multiplied with 0. That's why we can write it as a, this minus will take outside, a raised to n, this u of minus n minus 1 is 1 from minus infinity to minus 1. Otherwise, it is 0. So, 1 here, there is no need to write z raised to minus n. Now, let's solve this. X of z we got minus n varies from minus infinity to minus 1, a raised to n, z raised to minus n. Now, let's change this minus limits to the positive by putting L is equal to minus n. So the limits of L becomes infinity to 1. This when n is minus infinity, L is plus infinity. And when n is minus 1, L becomes plus 1. That's why the limits of L will be minus infinity to 1. Now L is equal to minus n. That's why this plus n becomes minus L. And this minus n becomes plus n. Now let's solve this. We can write lower limit lower to this side and upper limit to the upper limit. So you can write L varies from minus infinity to infinity. This minus sign as it is. A raised to, we'll take this L common to both, a raised to minus 1 z. Now we'll solve this. We'll put L is equal to 1, L is equal to 2, L is equal to 3, and we will get this infinite series. But we know the infinite series or infinite geometric series as a 1 plus a raised to 1, a raised to 2, a raised to 3, or any particular constant. So here we'll a raised to minus 1z common from each term, so that we'll get here 1 plus a raised to minus 1z raised to 1, then raised to 2, raised to 3, infinite geometric series. And we know the solution for infinite geometric series. So we'll get this is nothing but infinite geometric series, and we know the solution for infinite geometric series is summation n varies from 0 to infinity. That means b raised to 0, b raised to 1, b raised to 3 up to b raised to infinite. Solution is 1 upon 1 minus b, where mod b is less than 1. So here this we got b raised to 0 means 1. Then b raised to 1, b raised to 2, b raised to 3, like this up to infinity. So here b is a raised to minus 1 z. So this series is nothing but 1 upon 1 minus your b is z raised to minus 1 z, and this term as it is. Now how to solve this? and this b mod b is less than 1, b is z raised to minus 1 z. Now let's solve this. Here I will take common a raised to minus 1 z, so that here a raised to minus 1 z common, and this becomes a raised to 1 z raised to minus 1 minus 1 after taking this common, and this we can cancel. And what is ROC? Here z raised to minus 1 will take this side, so mod z less than mod a. So here take this minus inside and we'll get x of z is equal to z upon z minus a, where mod z is less than mod a is our ROC. Now how to draw it graphically? This is the z domain, real axis, imaginary axis. Now we'll draw the circle whose radius is a. Now check the ROC here, mod z less than a. So all the values of z whose value is less than a is our ROC. ROC means this x of z becomes finite for all the values of z which is less than a. That means this interior part of the circle where this z less than a. Outside z is greater than a. That's why this interior part of the circle is our ROC, region of convergence. So here we can say that our sequence minus a raised to n u of minus n minus 1, its ROC or its z transform is 1 upon 1 minus a z raised to minus 1 or z upon z minus a, same, and ROC is mod z less than a, interior of the circle. So here we can write the next property of ROC. If x of n is infinite duration, u of minus 1 exists from minus infinity to minus 1. That's why infinite duration, left sided. Your sequence exists only for n less than 0. That's why left sided. The ROC is interior part of the circle having radius a. This is the fifth property. Now let's check both the example which we have solved right now and in the previous video. In the previous video, we have solve the example for a raised to n u of n. Your z transform is z upon z minus a. In this video, we have solved example for minus a raised to n u of minus n minus 1. Z transform is z upon z minus a. In both the cases, you got same z transform, z upon z minus a. So where is the difference? Difference is in the ROC. In first case, for right-sided sequence, or you can say causal sequence, your ROC is mod z greater than a. And in the second case, for the left-sided sequence, or we can say anti-causal sequence, the ROC is mod z less than a. In the first case, mod z greater than a, ROC is exterior of the circle having radius a. In the second case, for left-sided infinite duration sequence, ROC is interior of the circle having radius a. So here we can say that for the right-sided sequence and left-sided sequence, Z transform is same. Where is the change? In the ROC. For right-sided sequence, for causal signal, ROC is mod Z greater than A, that is the exterior of the circle. Then for the anti-causal or left-sided sequence, ROC is mod Z less than A, interior of the circle. One more point I would like to add here about the stability of the system. The stable system, which includes the unit circle in its ROC. That means, for example, in this case, in the first case, suppose A is equal to 0.5. And what is our ROC? ROC is greater than 0.5. All the values of Z which is greater than 0.5. And it includes unit circle or not? Unit circle, its radius is 1. Unit circle radius is 1 means like this. So this unit circle includes your ROC. That means this system is stable system. Whatever this x of n is represent the stable system. In that case, we have considered a is less than 1. Then only your ROC will include this unit circle. So here we can say this system A of n is ROC exterior of A, where A is suppose 0.5 or any value less than 1. It includes unit circle, means system is causal also because of right sided, and it is stable also because it includes its ROC includes its circle. Same here, if your unit circle is interior of this A, your system is anti-causal because of this u of minus n minus 1. But if your A is supposed to, unit circle will be inside the this circle. That means it includes the unit circle, system is stable and anti-causal. If A is 0.5, circle is outside the this A radius A circle. That means it will not include in the ROC, means your system is not stable, but only anti-causal it is because ROC is interior of the circle. So this is all about the Z transform. Thank you.